welcome to my channel. In this video, I'm going to show you one big mistake you should never make when analyzing multiple response questions. I see some audience have asked questions regarding how to handle multiple response questions. And in my professional life, I've also encountered situations where non-technical analysts engage in gross mistreatment of multiple response questions. So I'm going to show you what is the right way to handle multiple response question. Why do we do that? And why is it that the other approach that people use are wrong and technically incorrect? And you should avoid that, especially where you are presenting your findings to a large audience. You will ask so many questions, and that can really impact your credibility. So I have, if you are familiar with multiple response questions, some call it select all that apply question, or um, it's a multiple response question, or check boxes, or whatever. So in a survey, what happens is that you ask respondents, mostly where the survey question poses a question to the respondent that require them, where applicable to them, to select more than one response item. So here I have two charts, one chart on the left and the other one on the right. Both charts are the same survey questions, and the chart are analyzed, or the result based on that survey question from the data. So now, if you look carefully, you might see some differences between the chart. But well, the difference is not just the color, but you will also observe the height of the bars. You see that they are different, but the same question, all right, the same number of respondents. So why is one different from the other? And how do you go about this in the correct way? All right. So I have a survey question where in the survey we ask respondents, which of the following devices do you own? So electronic devices. So naturally, we all know in the population, if most people naturally, you have people in the population that will have more than one um, electronic device, especially those that we listed here. So we have feature phones that are keypads, and that came early in the days before we now have screen touch and all that. And we have smartphone, tablet, laptop, and desktop. So naturally, we know in the population, if we're going to sample population of people even age 18 and above or whatever, there's a chance that they'll own more than one of this. So it's necessary, since the question is posing about what they own and not what they use frequently or in most part of their daily life. So naturally, it will prompt that some respondents should be allowed to select more than one. So we collected this data, we analyzed it, and we had this chart. So now the charts are two different things. So what is happening here is that the chart on the right, if you observe, if you add all the the percentages, it's add up to more than 100. And the one on the right add up to 100%. The same model, the same survey question, same responses, and so why are the percentages different? And which one is correct and which one is wrong? All right. So, but before we go into that, I want to go back to just to give a brief background about what survey is about. So, survey, naturally, you have a population of consumers. So, let's say population of students, or a population of community participants, head of households, and so on. And you can't go around to get information, or you don't already have information about every household, the number of devices they use, and so on and so forth. And then, even if you do, your data might be limited to the households data you have. You might not have every household data. So you still need to kind of get some information from the ground. So you do a primary research. So here, a survey, we all know, generally picks a sample from a population. And then you gather data using survey questionnaire or any kind of research instrument. And survey basically is based on a sample size. And the idea is that you you kind of have an information from that sample that we call a statistic. And then the idea is to be able to use the statistic from that sample and then infer it into the population, which is the real information from that population is the parameter, right? And then you want to get information from this sample and use that to see how close that statistic would be to the parameter in the population. So in that case, you can reach out to everyone. So whatever information you are going to get from the sample will be based on the number of people in that sample. That's the sample size. So any information in reference will be about the sample size. So in the first chart on the right, on the left, you see that we have 94% of the respondents say they have a smartphone. You see how I implied 94% of the respondents. So, or sample respondents. So, because the reference here is the sample. So, out of the sample that we have, 94% of them say they own a smartphone, right? So, the reference is on the sample. Then, and that makes sense. So, for example, you get customers and you find out about, their level of education. You find now that half of them. So, you are referring to the sample reference here, and that this one is the proportion. So the statistic here, the estimate from the sample or the summary statistic from that sample is a proportion, and that proportion is based on the sample size. So any interpretation or reference will be in reference to the sample size or the sample responders. So which is the right way technically to look at it, right? Okay. And then you have what we call confidence intervals, margin of error, whatever. That you want to really see how far, if you were to sample another, take a sample from that same population, what is the confidence that you get 94% of them or within some interval, right? For maybe plus or minus 5% range or whatever. And that is the right way. We all know technically is how to do it. So, but I've seen people ask why the multiple response questions, my previous questions or multiple response survey questions do not add up to 100%. I've kind of answered some of them, but I've seen it recently in my professional life where people just, go about the proportion on their own way. And sometimes you want to explain to them and they don't understand why it shouldn't up to 100%. So, and that's basically it. So now let's go back to our survey question. So in the survey question, you ask respondents about this survey question, for example, and then we have our data here. So depending on the platform that you are using, your survey outputs, the data might look a bit different. How the multiple response question come. I've covered all different kinds of survey questions in my previous videos. You can check them out to understand how to analyze. But in this case, we have a survey data here. It's the same question that we have. Which of the following devices do you own? But in this kind of survey data, each response came in separate columns. So a respondent selects one of the responses we have and it comes in one column. You select second one, it comes in a different column. So you have each the multiple response appear in multiple columns. Okay, and this is one way that the survey multiple response survey data could come. There are other ones where they come in a single column separate. The delimiter, so I've covered all the videos on that. You can check them out. So now what happens is that we have the question 5 stars from here, and each one is indexed by 1. So this means that this is the first response that the first column here is the first response that the respondent selected, the second one, and so on. So in this type of multiple response question, the selections appear in each cell, in each column, and then where the selection, the respondent didn't make a selection for that column, then it's blank like here. So if you look, the first respondent ID 1, who is a female, 24-year-old, lives in an urban, has highest education of being secondary, they are unemployed or between work. And then in the first case, they didn't own, so they didn't select anything here. And the second one, they selected a smartphone, so they own a smartphone. So if you go further, they didn't select any other one. So that means this respondent owns just a single electronic device. Okay, so there's a way to know how many people owns a smartphone, only how many people owns two devices, three, and so on. I will cover a separate video on that, how to get that kind of proportions from your multiple response question. And then respondent number two select the tablet and it appears in a different column and so on. So how do you analyze this one? I've covered a video on that, but we're just gonna use this example to demonstrate why one approach is the right way and the other one is something that you should never commit as a mistake. All right, so first let's load this to Power Query. So we go to data, from data we go to table or range, and we load our data to Power Query. All right, so let's name this multiple response data. Okay, so this is a multiple response question where each selection appears in a single column. So what we are going to do is that we'll select all the columns of our multiple response question. So we have question 5, starts from here. Just click on the first column, hold down your shift key, you scroll to the right and select the last column. So but let's check the last column seems blank, so we can just ignore that. So we select all the columns. So if you want, you select each one whilst holding your control key. So and then you continue to select. So let's select all our response question. We can leave this one because this is blank. So once we select, we can right click on any of them on the header, then we'll go to pivot only selected columns. All right. So what we have here is that we have two columns added. One is attribute, which is the question. We don't need this information, so we just delete it. So we remove this one, and then this is our multiple response question. Okay. All right, so that's it. So this is what we want to analyze. So we are done. We go back, we'll close and load this. Let's add this let's just establish connection alone. We don't need and add to data model. Okay. And then this will be added to data model. All right, so let's go to analysis where we want to generate our pivot table. So let's put our pivot table here. So we go to insert from pivot table. You can insert from external data source. So we've loaded it to a data model, so it should be in there. So if we go to table or range, we want to generate a table from there, and there you will not be able to pivot like with this. So let's source our data from here. We select connection. So let's look for, this is our multiple MR data, right? So it's good to always name your data tables and Power Query. Okay, and then we want to we want to generate a pivot table here. So let's click here and then okay, and our pivot table will come. So here on the row, let's pick our multiple responses, drop it in the row field, and then we look for ID and drop it in the value field. Okay, so by default, this one will sum up because they are numeric. We don't want to sum because each ID is numeric. So if we sum, it gives us quite a large number, right? So we want to count. So there are two count functions. In this case, we have distinct count and just count. So now, do we want to count or do we want to use distinct count? So what is the difference here in respect to this data? So what is happening here is that if you go back to your pivot, your Power Query, you realize that when you unpivot, your data gets a bit longer. So in we call it you've stacked the data, so it becomes a very tall data, right? So which means that the IDs will repeat. So just to get a sense of that, let's go back to our Power Query and just open the Power Query editor. Okay, this is our table. So let's go back. So you see that after I'm pivoting, you see that the IDs repeat. So in the first respondent selected only smartphone. So you realize that their ID is just one. This person selected two, so the ID will repeat two. This person selected three devices in that order. So the number of selections by each respondent will be repeated. So if we take sum of IDs, it doesn't give us the total number of respondents, right? Okay, so let's close this and come back to our P4 table. So what we need to do is to summarize values by count. That's the first option. So the number of respondents in our survey, if we check here, the number of respondents in the survey is, we have it. Okay. So now, let's go back to our table. So we have this, and then another thing we can look at is, so now we have 74, right? Okay, so 74 here. But if we check in our data, the number of respondents we have in our data, if we want, we can sort this ascending or descending order. Okay, so we have 54 respondents in 50 respondents in our survey. Let's just count this. So we have 50 respondents in our survey. So that is the sample size, right? The number of respondents. Of course, this is for demonstration. 50 is quite a small sample. All right. So now, but we have 74. So what does this 74 mean? So let's see. So 5 people selected. Let's sort this in descending order first, so we can know which one has the highest frequency, right? So we have 47 respondents selected that they own a smartphone, but because they were allowed to select more than one, if you add all their selections, you see that it will give you 74. So what this means is that this 74 is the total number of selections. It is not the total number of respondents or the sample size. So if you are interpreting your chart and you say that 74% of sample respondents own a smartphone, then in that case, your interpretation is already wrong, because you are making reference to the number of selections. Your proportion is summarized from the number of responses. So you can interpret it by making reference to the sample, because the sample was not the base. Your base here was the number of selections, which is not the case for survey data. In survey, you want to get a summary statistics that you can use based on the sample size to infer into the population. So if your statistic is based on number of counts, then how do you relate it to the sample? So that's why you need to estimate your statistic, that is proportion in this case, from the sample based with reference to the sample, right? So if we take proportion here, if we take column percentage, you realize that our column percentage is based on the base here is 74, and this 74 is the number of selection, total frequency of the response items, but not the total number of respondents. So in that case, you realize that your percentages add up to 100, because this is based on the frequency of responses. But the idea of the proportion, we want to know out of our sample how many people own a smartphone, but not out of the number of frequencies, or the sum of frequencies, how many of that sum of frequency own is matches or comes from a smartphone. So in that case, if you don't even, how do you even interpret this in this case? Because the base here is 74. And this 74 is the sum of frequencies of the multiple selections. So you can't even make reference to the base here, the sample size. So, and this is this is a very big mistake you should always avoid. So how do we pass through here? So now so this is our table 1. Let's just copy this one down, and then now let's go back, and we have summarized by distinct count. So now if we summarize by distinct count, you see that the base here, let's check what the base is. Let's remove calculation. So you see the base here is 50. And this 50 is the number of respondents in our survey. So this is a sample, the complete responses we have in the survey data, right? And this is the base. So these are the real respondents, the total number of respondents in the survey. And the idea of the survey generally was to find out of the number of respondents who are in our sample, how many of them, how many or what proportion. So our statistic here is proportion. What proportion of our sample respondents own a smartphone? And that is the idea of a survey. So in that case, the right thing to do in a multiple response question when you are analyzing is to ensure that you are taking the proportion out of the total number of respondents in your survey, or out of the number of respondents in the survey who answered the question. So in that case, your base description, if it is in this case our base description, so the base here is the reference sample or sample size. Here is the total sample or total number of respondents, right? So that is the base. So if we take proportion out of this 50%, we'll be able to interpret by saying that out of the let's, for example, 20% of the respondents own a smartphone, right? Or if it's a student, you say that more than half of students or sample students own a smartphone. So here the reference is on the sample because the proportion is coming from that sample or subsample. So because in some cases, not all some respondents in the survey, if they are skipped, to answer a specific question. So if you want to base on that, those who really answered the question, then you need to describe that base correctly with the right description. So here, these are two different things we have for our same survey question, same number of selection frequencies for each response item, but here the bases are different because here this count, you see distinct count and then count. So the counts the number of IDs after we have pivoted. Remember, we start with data to be able to summarize it. So it counts the number of IDs. So even if the ID is repeated several times, it will sum it and the grand total will be that total, right? And then here, distinct count counts the number of distinct IDs. And remember that the IDs distinctively identifies the respondent in the survey. So if it counts the respondents in the survey or those who answered that question, then in that case, that is the real sample or subsample that you should use as your base to take proportion. So the big mistake most people make is that they just go forward to take percentage using the count. So they go further to say percentage of column total, right? So our column total here was 74. And then what do they find? So they find that when they add all their percentages, it add up to 100%. And they say, oh yes, percentages will add up to 100%. Yes, in a survey, it's not always the case when the survey question is a multiple response question, because respondents in the survey are allowed to select more than one. But if it is a single response question, they must add up to 100%. And this is the mistake that you should never repeat. Or if you have done it in the past, you should never. It's statistically, in fact, it is statistically incorrect, and you'll be disgraced in presentations because most, audiences of survey report presentations are used to multiple response question. So you just have to add some small description to the chart. For example, like in this chart, to indicate, to clarify to the reader that this is a multiple response question. So in that case, people could select more than one. Okay, and that is it. So this chart are based on the chart on the right is the wrong chart. You should never, unless you want to say that, okay, my base is frequencies. In that case, what is the purpose of the survey? Because you'll not be able to interpret the statistic with reference to the sample or subsample, which in that case, you don't have any information about the realistic information about the sample that you can use to infer into the population, right? Okay, so here the correct way is to use distinct count. So you use distinct count, 50, then you just divide by column total. Good. So here you realize that it doesn't add up to 100%. So let's take sum of percentages would add up to more than 100% because respondents were allowed to select more than one response item. So for example, smartphone, it means that almost all of them own a smartphone because 47 of the respondents selected that they own a smartphone, right? So this number could include others who own other devices. So if you want to know how many people own just a smartphone, there's a way to handle that. I will cover that in a separate video. So here, if we take percentages by the sample here, the sample or subsample, it will not add up to 100% in most cases, because once a survey question is multiple response, there's a natural chance that someone will select more than one, and that's why you made it a multiple response question. So if we sum frequency, you see that the frequencies here are 74. So if we take 74%, right, 74 divided by 50, you realize that we'll get 148%, and that's why your percentages will not add up to 100%, because the sum of frequencies are more than the number of respondents who gave you that frequency. So if you add up that percentages, they mostly will be more than 100%. If it is equal to 100%, then the question is just like a single response question, which mostly is multiple response questions, unless you wrongly construct a question that was supposed to be multiple response question. So that's how you handle that. So always make sure that your multiple response question is treated appropriately. So in most cases, they will never add up to 100%. Most cases. So what happens is that once you build a chart with these two different one is the count on the right, you use count. So you realize that all this add up to 100%. So once it's added up to 100%, a column bar chart like this is not the appropriate. So the best way to show that they add up to 100% would be to use 100% stack bar charts, because they add up to 100%. Right? But maybe sometimes you want to highlight the top device. So by here, if you are using 100%, here the base cannot be 50, because your base, the percentages were not coming from 50, which is the number of respondents. So you may be tempted to say your base is 74. No, because this 74 is the total frequency, and the idea of the proportion is to find out how many of the respondents, not because this 74 is the number of sum of frequency, right? So it's not correct to even say your base is equal to total frequency, and then what in total frequency here is not equal to the base. So in that case, you are not kind of making an estimate from the sample, which means that it's totally wrong to go forward to say that 64% of your sample or respondents own a smartphone, when that 64% is not out of the 50 respondents in the survey. So, and this is the biggest mistake you should not do when handling a multiple response question. So the right chart is on the left here, because this 94% for smartphone is coming from 50%. So someone can just take the percentage and know that, just multiply this by 50, and they will know that 47 respondents say they own out of 50, right? And that is from the sample. So you are able to come up with a statistic from the sample. That when you know that if it's done well, if the sample is enough, it's representative, and so on. If you go back, sample again from the population, there's a chance within some level of margin of error and confidence level, you'll be able to get, almost close to what you have from the sample. And that's the purpose of the survey. All right. So thank you very much. See you. Bye.